In this series of videos, we will look at streams, which we've already used for input-output to the console and keyboard. And we'll also do file I/O. So read things from a file and write things out to a file. So tremendously useful thing to be able to do. Is one of the essential things you should be able to do in any language. If you're learning Java, you should be able to read and write to a file. If you're learning C++ or C, definitely you want to be able to read and write to files. Okay, so what do we learn? We're going to learn about input-output streams, how you want to think about streams, to do character I/O, file I/O, character I/O to the terminal. We've done terminal/keyboard. We've done that, C in, C out. And then the new thing is would be doing I/O with files. So we will look at tools for using stream I/O. We will take a look at how we handle files. Remember, so if you remember from Java, you need the name of a file to open up a file, but once you open up a file, you no longer need that name anymore. You don't do anything with the file name itself. What you do is use a buffered reader, let's say, or a print stream for output, buffered reader for input. You just need that stream. It's the same idea in Java. It's just used used a little bit differently, especially with those insertion and extraction operators. So the same idea. Once you open up a file for reading, do you need that file name? Not really. If the file's open, you just deal with the stream after that. For output, there's also settings that you can use to format the output, and then we will look at stream hierarchies, and maybe we'll get to random access to files. So the idea in C++ is that streams are how you're supposed to transfer data in a persistent way. And in Java, there's a totally different take on this sort of the same idea, but in Java we use two techniques. That is, we use the toString method for all objects to convert an object to a string, and the other thing is we use serialization. So if you remember serialization, we treat each object as one thing that can be put out to a file, and that file may actually be a network connection. And we have the same idea in C++ too. Streams are a little bit abstract, and purposely so that you can, rather than put stuff to a file, you can direct that stream, let's say, to a network connection, and everything should work. That's the idea. So there's a lot of common things, but then a lot of differences too between Java and C++. Okay, so let's take a look at streams. These are special objects to deliver program input and output. So you want to treat these as special objects. You don't need to know exactly how everything works. The idea is that in C++ we use abstraction. Later on we can look at more the details of how these things are done, but for now let's treat them as abstract things. You want to think of, let's say, a network connection or a file. You want to think of these things as something that accepts, let's say, character input, or something that delivers a stream of characters, and we just want to be able to take that stream and put it into our memory in our program, into a variable or an object. So we want to keep things a little bit more abstract and think about streams as special objects. So the thing about file I/O is that it uses inheritance, and normally this would be a problem because we don't cover inheritance between classes until chapter 14, but assuming that most of you, or almost all of you, have seen inheritance Java, I don't think it'll be a problem. So let me know if it is, but I'm guessing that because file I/O uses inheritance, it's not going to be a big deal, just because you, I'm hoping, have seen inheritance in Java. So despite this fact, most people cover file I/O very early on, well before we actually see how to use inheritance in C++, because It's so important, so useful. Okay, so what exactly is a stream? You want to think of it as a flow of characters. An input stream is a flow of characters into program memory, and this flow can come from the keyboard, and that's what all we've been using. Cin, console in, that's basically the keyboard. Or it can come from a file, and that's what we will do in this set of videos. An output stream flows out of a program, so memory or objects or things flow out of a program, and so far we've been using cout. That's going to the screen. Now we will start looking at how we can get objects from our program to go to a file. And it turns out there's not a whole lot of difference. Once you get used to setting up input and output files, you're pretty much set. So we have used streams already. As we said, Cin is the input stream connected to the keyboard. So you don't want to think of Cin as connected to the terminal. I don't think that's a good way of thinking about it. It's much better to think of input stream Cin as connected to the keyboard. Now what happens is that when you run a program, everything that you type at the keyboard is echoed in the terminal, and so most people get the impression that the keyboard somehow magically is connected to the terminal, and so when you press keys, that's the terminal that actually generates the input that goes into the program. No, actually what happens is Cin is pretty much directly connected to your keyboard. Cout is connected to the screen. So when you put stuff out, when you put a stream of characters out to cout, it goes, it's displayed in the screen. Now it turns out, and so I just want to say it one more time, Cin, it's connected to the keyboard. Just so it turns out, almost every program will echo whatever character you type in on the keyboard to the screen so that you can see what you're typing, right? So it's not like input stream is connected to the console, it's actually connected to the keyboard. Okay. We can define other streams, to or from files, to or from network connections. We're probably not going to do that this semester, but it's not that hard to set up. And these are used similarly as in Cin and cout. Okay, so let's say we have a program that defines an input stream that comes from some file. What can you do with it? Let's say you have an integer. You can read things from the input stream into that number. So let's just set up a simple example. Here's our example. This is like a hello world program. I took advantage of the using declaration to just use cout and endline, rather than importing all of the names in the standard namespace. I'm picking and choosing which things I want to import. So now, let's say I want to read something from an input file. I'm sorry, from the keyboard. I'm getting ahead of myself. You can do something like this. X, Cin, like use the extraction operator into X and say int X. And before that, we should ask the user to type in something because it won't be obvious. Okay, let's do that. And we don't want an end line, we just want to say please enter your age, and on the same line we want to read in some input. So we can do this, stdcin, and once this is entered we can say cout. Say please and thank you. It's the basics of user interaction. Alright, oops. There we go. So let's see if this will work. Compile this. Good. And let's run this. It says please enter your age, and most of you are probably this age or younger. Alright, so what happened? We said sent out the stream of characters to the console output, and then we said we would read in something into this X. So this stream of characters goes into X. Now the extraction operator has been overloaded, so that if you're going to read to an int, you take whatever character the user types in, and so what the user types in is a 2 and a 5, and that 2 and a 5 is converted in the implementation of this overloaded extraction operator to create an int out of the 2 and the 5. So it actually does a 2 times 10 to the power 1 plus 5, which gives you an int 25, which is then put into X. So if you were to run this again, and then you say please enter your age, and you just type in something else, what happened was that it took the TONY and then tried to convert it to an int, but ended up with this number, so it couldn't do it. So you can enter anything you want. In Java, you would probably get something like a parse int error if you type in letters when it expects numbers. And if you type in a large number, you will get that. Okay, and you probably also know that with spaces, so the number, like let's say you type in 23 and then space 34, it'll just take the 23. The 34 is just discarded. It's never going to see that, because you take in a sequence of characters that make up something that looks like an integer, and then the space is the delimiter. After that, it stops reading when it gets to the space, and so it thinks that you entered a 23. Okay, so I'm hoping that makes sense. That's a very simple stream setup. Get input, output, and there are some rules that you have to keep in mind if you're reading in ints. Similar rules for strings, so you can make this a string, and pretty much everything will work. And then let's say and remember that space is the delimiter, or a space or tab or new line character. So if you run this, it says please enter your name. That works. What would happen if I enter my first name and last name separated by a space or a tab? I'm going to put in a space and hit enter. And of course, you've probably seen this kind of thing before. The space means you stop reading, and so you only read, when you do a cin, you only read up to Tony. That's all you have in your program to read. If you now do another extraction from cin into some other variable, you could probably read the next string. So this is one string, the way streams work, and this is another string. Okay, it's delimited by white space characters like space, tab, new lines.